All right. I have a question. Feel free to ask the question. I assume that Terry, you are typing, so I will. Uh, if it's possible, you can unmute your mic and let me know your question. Here it is. I'm not sure you mentioned it already, but what are the common use cases of linked list versus arrays? Use cases. So I talked about the use cases of the linked list here. There we go. So yeah, these are the so okay. I get it. So you're the reason. So for the purpose you are asking, so that is totally different from these real world examples. I can tell you about that, but here I'm not sure if you were here and or you joined a bit late. But here are some of the real world examples. That is the music player, the image viewer, the buttons in the Spotify, the SoundCloud, your file explorer, browser, etc. Where you have the back and next button, so that working of the back and next button work. The algorithm behind that, or the data structure behind that, is the linked list. Now, talking about the common ways to identify when to choose one over the other. So let's quickly talk about that. How can you identify? So, for example, if you have two options and you're not sure which one to use for that specific purpose. So when you know you need to insert something, it's better to use a linked list, because exactly, yeah. So to understand that, how to identify which one to use when, you have to understand the attributes of both. You have to make sure that you have a very good idea of the attributes of the linked list and the attributes of the array. So what I mean by that is you need to have a very good understanding of what's the big O notation of insertion in both? What's the big O notation of getting accessing a specific index? What's the big O notation of inserting a value at the end? What's the big O notation of inserting a value at the start? Now, I talked about this for the arrays in the last session. We talked about what happens when you add a value in the last of the index. So that's O of 1, because it's just one single operation when you add something at the end. But when you add something at the start, that's O of n, because every single value is moved to the next side, to the forward. But if you try to get if you try to access if you try to get access to an index, that's O of 1, which we just talked about as well. So these are the attributes of the arrays. Now, keeping that in mind, and depending on the use case of whatever the use case you have, whatever operations you're trying, or whatever project you are building, depending on what are the operations that you're going to use the most, based on that, you can decide which data structure is the best for that project or use case or scenario. So, for example, as Carson already mentioned, if if your scenario or the use case has the need of inserting a lot of values in some random positions, so the best approach would be to use the linked list, because in the linked list, if you insert any value at any place, it's always going to be O of 1. But in case of arrays, that's not the case. The worst case is O of n. For example, if you insert it in the first or second or third index, so that's O of n. So if it involves a lot of insertion, so that means that you have to use linked list. But if it involves a lot of accessing the values, arrays are basically good at accessing the values. So in that case, you can go for arrays. For example, if every time you have to access some random indexes, so in that case, arrays are a good data structure to use in that case. So that depends on how you want to use like what's the use case or what's the purpose or what's the scenario. So based on those things, you can decide what to use. Now, this is something that is applicable to almost any data structure. So which means that you need to make sure that you have a very good understanding of the attributes of most of the data structures in order to make a decision of which data structure to use. Now, does that answer your question? Awesome. All right. Okay, so let's talk about the types. So here are the types. So the first type is a single linked list, or a single linked list, which looks something like this, where 1 is connected to 2 and 2 is connected to 3 and so on. But so it's connected from one side, but if you go from this other side, I mean, 1 is connected to 2, but 2 is not connected back to 1. Similarly, 2 is connected to 3, but 3 is not connected to 2. So there is a one-way connection. Whereas this other type known as doubly linked list, now in this case, 1 is connected to 2 and 2 is also connected back to 1. So this is like a this is a two-way connection. Now that is another type of a linked list. And then the third type is circular list, where we have 1 is connected to 2 and 2 is connected to 3, all the way up to 8 is connected to 9. But then 9 is connected back to 1. So the circle is a closed circle. Now that is known as a circular linked list. In the previous two example, the 9's next node is empty and 1's previous node is empty. But in this case, 9's next node is 1, and so this is a closed circle. There is one other type that I have not mentioned here. That is a doubly circular linked list, a circular doubly linked list, where it's the same closed circle, but the connection is two-way. So which means that in that case, 1 is connected to 2 and 2 is connected to 1. 9 is connected to 1 and 1 is connected back to 9. So that's a two-way connection, but again, in a closed circle. So these are some of the types of linked list. So moving on, let's do a quick progress check, and then we can move on to the hands-on. So if you have to add 10 in after 5, so how it will be? What will be the new connection? Like what's going to be the 10's next node, 10's previous node, 10's next node, and 10's previous node, if you have to add 10 after 5? One, 2, 3, 4, 5, 10, 8, 9. Exactly. Find the 5th node, insert 10, change the next node of 5 to 10, change the 10's next node. That is a very good answer. You wrote the whole pseudocode. And that is something that if an interview asked me the question about add 10 in after 5, I would exactly phrase it like you did, Arvind. So thanks for putting that. All right, so yeah, everyone is correct. 10 snacks should be 8, and then 5, the previous is 5. Yeah, and so yeah, that is correct. Now moving on, set 14 as a header. So if that is something that you have to do in this case, considering this is a closed group, how would you do this? Someone raised a hand. If yes, feel free to unmute.
Yeah, what do you mean as header? I don't understand.
Oh, so basically in the linked list, there is a terminology known as a head node, and the head node is always the first node. So in this case, the header is this one. Yeah, the root node. So that is the one.
Okay, so it would then replace that place in line.
Say that
If we're
again.
so if we're making it the header, basically it becomes the first node and then connects to 1 and 9 as the two other nodes that's connected to, correct?
Exactly.
Awesome.
So we set 9 to 14. Yeah, so we set the head node as 14 and then, oops. So yeah, we set the head node as 14 and then sets 9's next node to 14 and then 14's next node to 1. So which means that here it will be 14 and then here it will be 1, 2, 3, 5, 4, 5, and so on. So there we will add a new node here that will be 14 and 9 will be connected to that 14. So yeah, that is how it works. So this was the basic introduction to linked list on their usages, their types, some examples, and how it works in general, and what is a head node. So with that, let's move on to the interesting part, that is a demo. So we will be spending most of our time now here doing a demo and try to make a linked list from a scratch. So before I jump into that, if there is any question, feel free to ask. All right. Awesome. Okay, so what we are going to do here is I have the pseudocode for almost every single operation, that function that we will be trying to build. But what I will be doing here is I will start with the, I will make the basic class for this, and then we can jump into this. So again, I will be doing this in my DevTools. So keep things simple. And this should be in the sources. So we're going to test. All right. So I will start with the, I will make the structure, and then we can start writing the code for the push value. So the first thing that we need to do is, for every single value, there is a node. So we will start with that, and we will make a constructor for this. And this will be accepting a value. And then every node has two things. One is, to keep things simple, we will go with a single linked list, but the concepts are same. If you understand one, you can write the code for the other three as well. So every node has two things. One is its value, and the other one is the connection, the next node. So this will be this dot next equals to null. All right. With that being said, we will make a linked list here. So linked list, and then starting with a constructor. So initially, when there is nothing in the linked list, there are three things. One is a head node, a tail node. This tail node is not important, but it's useful to have. And then the last thing is length. So we will keep track of the length of the linked list. But remember, the most important thing is the head node. That's the minimum that you need. All right. With that being said, let's start with the first thing, that is the push value, or the push function. So basically, push is a function that helps us to add anything at the end of the list. Pretty much the same way it works in the arrays. So if we have to write a function that is push, so first thing is it's a function that accepts an argument, because we have to insert something, and that new value has to be given by the user. So here is the pseudocode. We create a new node, and then we check if the head is empty. If that's the case, so we set the head and the tail to the new node. If that's not the case, which means that if head is not empty, we connect the tail with the next node and set the tail to the next node. So this may be a little bit confusing, because there are a lot of back and forth connection, but it's pretty much the same as we did in one of the example that was at 10 after 5. But the only thing is the next node is going to be null. And yeah, the last three we have to increment the length by 1 and then return the length. So let's try to do this, and I would love if I can get some help from the fellows. If you are not sure about the answer, that's completely fine. I would just love if you can interact with me, and even though if you give me an incorrect answer, that's also completely fine. Okay, so the first thing is we make a new node. So I will make a new node that is, so this is how you make a new node in JavaScript. Then the next thing is we check if the head node is empty. So we do something like this. If this dot head equals to undefined, what we can do is we add an exclamation mark here. And this basically means that if this is undefined or if this is empty. So what we do here is we set the head and the tail to the new node. So that will be this dot head equals to node, and then this dot tail equals to, we can also do this node, or we can do this dot head. Both are same thing at this point. So that is the first part. Now, the second part is if the head is not empty. So what happens is that we make an else, and then we set, first thing is connect the tail with the next node. So what we do is this dot tail dot next equals to, now this next is from this nodes constructor. It has this next value, and every head and tail is basically a node. So that's why we have this dot tail dot next equals to node, and then it is set the tail to the next node. So then we set this dot tail equals to node. Now what happens here is, for example, if you have a list like this, so what happens is it will be and I want to insert 10 here. So currently this is the tail node. So what happens is it set this dot tail dot next equals to 10, and then at this point, this initially this is a tail node, but then when we set the tails next to 10, we set this dot tail equals to node as well. So that means that we set the tail to 10. Now this is the tail node, and that's how easy it is. And then the last thing is we get out of this if and else, and then we change this dot length plus plus, and then do we have to return anything? Yes, we have to return the length. So we just simply do return this dot length, and that's it. Now that is how you write the code for the push value. Now before I test this. If anyone has any confusion about the code or any part of this code which you didn't get it, probably maybe because it's in a different language, feel free to ask. Otherwise, give me a thumbs up if you get this. Well explained, very clear, awesome. All right, let's test the code. So in JavaScript, this is how we do it. So we make we have the new class, and we make an instance of that class. And then what we do here is I will just do list here, and we get this list initially that has a head as a null and tail as null and length as 0. Now what I do next is I do this list dot push 2, and then list dot push 5. And if I do it again, so I get 2. And if I now copy this and paste this here, and now I test this, so I can get a head which has a value of 2, the total length is 2, and the tail is 5. And that makes sense because we have 2 values. The first one is 2, and the next one is 5, and the 5 has null as an empty node. So yeah, this makes sense, which means that this algorithm is correct. All right. I thought we should set the tail of an empty list to null when we insert the next value, if it's not a circular linked list. You set the tail of an empty list. We are already doing that. So initially, when we create the list like this, the constructor function is called this function. And what happens here is that this dot head is null, this dot tail is null. So that is how we set the tail to null. Now, if you're confused by thinking about, for example, if we have something like this, and you are thinking about that the tail is 10's next node, because like it's something like this, because this is the last node and this is going to be empty. So if you're thinking that this is the tail, this null. So no, that's not the tail. The tail is going to be the last non-empty node, this one, because if we keep this as a null, so that that means every time we have the same value in this node. So yeah, but we initially make this empty, and then we make this as the every time the last node. Someone has a question. Someone raised the hand, I believe.
Yeah, I had a question. So I'm just
Mhm.
a little bit confused because the 10 here is the tail, but have we actually introduced that into our equation yet? Do we need to do another list.push for 10 in order for that to
Yeah,
actually be there? Okay. Okay.
yeah, we have to do it. So so with this example, like this, in this case, it's like this.
Okay.
We don't have any 10 here. To add a 10, we have to do this dot push.
Okay, cool. And like when we see this in things like HackerRank, will they normally create the list for us, or is it something where we're going to need to push those values when we're looking at the problem?
So it usually you have to make your own list, but it's not like you have to make a whole list from scratch. You will be using these functionalities, and it's not like you have to make the whole linked list from scratch, including every single value, and then use it. It will be something you have to do about a linked list, but then you have to just use one function of that. For example, let's say you have to add this one function for that, and that will solve the problem for you.
Okay, cool. Thank you.
All right. So moving on to the pop value. So pop is exactly opposite of the push, which means that it removes the value, it removes the last value, which means the tail. So here is how it works. If the head is empty, which means the list is completely empty, there is nothing in the list. In that case, you just simply return undefined. If that's not the case, keep checking if the next node is the last node. So you start with the head node and keep checking if the next node is the last node. And while you have this loop, what you do is make the next node. If you find a node which has a next node as a null node, what you do is make this next node null and decrement the length by 1. So basically, you delete one node. And then if the total is 0, once you delete this, you will make the head and the tail equal to null. This may be confusing, but once you write the code, this will make complete sense to you. So let's write this. So what we do here is we make a function that is pop. And the first thing we do here is if the head is empty. So what we do here is if this dot head is empty, we return undefined. So we are just done with the first part. Now, what happens next is keep checking if next node is the last node. So for that, what we do is we will make a new node here. That is the current node, and we set that to head. And then what we do is new tail equals to current node. Now we make these two functions. We make these two variables, current node and the new tail. Current key, both of them refers to the head node. Now what we do here is we check if current node dot next. If this exists, now this statement, if you're from a C++, or Java, etc. background, this statement means that it has something in it. Current node dot next has something. So if that's the case, what we do is we set the new tail equals to current node. We update the tail, and then we update the current node equals to current node dot next. So this current node is I was trying to go one node ahead of the new tail. So initially this is going to be, so if I make this something like 15, and again, this example is not this, and the numbers you see here is not same of these. You have to add 15 here if you want to have result like this. But yeah, so initially this is going to be the current node. So I'm going to define current node as C and the new node as defined as N. So C and N, both of them are here. Now, I will write some code here and then we can talk about that. So, okay. If we have to, so the thing that we have to do is we have to get on this node 10, that is the second last node, and then remove this 15 and make it something like this, so that 10's next node is null. So how do we do that? If we go for 15 and then see the next node, so that is null. But then the problem is we cannot go back from this. So what we do is we stay on the 10, we check the next node, and then we check the next node's next node. So that is how we can do it in this case, because in the current case, we cannot go back. So we can only check it from 10. So what we do here is both of these are at 2. So initially, while current node dot next, so which means that current node dot next is 5, so this exists. So new tail is equals to current node. So a new tail is equals to current node. So both of them are at the same point. That makes sense. But then current node is equals to current node dot next. So current node will move towards the next node. So that is the C. And then it will check again if current node dot next exists. Yes, it does, and that is 10. In that case, set the new tail to the current node. So we set the new tail here and remove it from here. So now both of these values are at 5. And then current node equals to current node dot next. So we remove current node from here and then set it at here. And then we again check if current node dot next exists. Yes, that is 15. So set new tail equals to current node. So we do that here and we remove it from here. And then current node equals to current node dot next. So we remove current node from here and set it here. And then lastly, we again check if current node dot next exists while we are at this place. No, current node dot next equals to null. So that does not exist. So that is the end of the while loop. And then we get out of the end loop. Now at this point, we have something like this. The current node is 15. The new tail and the new tail is 10. So what we do here is make the next node null. So what we do here is we simply do this dot tail equals to. So what is the new tail? The new tail is this 10. We want this 10 as the new tail. So we can simply do new tail here. And then this dot tail. So currently we set this tail, but this new tail has a next node of 15, and we do not want that. The tail's next node is always null. So what we do here is this dot tail dot next equals to null, and that's it. And then lastly, we do this dot length minus minus. So what this will do is this will set the new tail, and then this tail dot next equals to null. So when we do this, it removes this, and that value has no connection with this 10 anymore. And then lastly, what we can do here is we will return current node dot value. And that will return that 15 for us, the value 15. But one thing here is, imagine if we had something like a case like we had 2 and then null. So in this case, if we try to remove the last node, that is 2. So if we try to remove this will be something like this. So if that is the case, we make an if statement here. We make an if statement and we see if this dot length equals to 0. This should be actually before the return statement. We make an if statement here, and then what we do here is we check for if this dot length is 0. If that is the case, so we just simply set this dot head equals to null and this dot tail equals to null, and that's it. That will solve this edge case, and then we can set head and tail to null, and that's it. So that is the pseudocode. That is the algorithm for popping something out of a linked list. So let's try this, and if anyone has then any question, feel free to ask. So let's see if this is working. I just did, let me do this again. So I just did push, 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 and then pop. And if I do pop, the length is 2. That makes sense. the head node is supposed to be 2. That makes sense. The tail node is supposed to be 5. That makes sense. Which means that we don't have 10 here anymore. So yeah, the tail is 5 and the next node is null. So that does make sense. Now, anyone has any question about this, any confusion, feel free to ask.
I'm a little bit confused. So
About what part?
Yeah, with pop, does it not pop off the front, or is that only with arrays?
No. So with the pop, it pop off the last value, not the
Okay.
front value. So if I do it with array, you see it pops 5.
Okay.
Even with arrays, it also pops the last value, not the first value.
Okay, thank you.
You're welcome. The first value is shift. The last value is pop. All right. So we're done with the 2 commands. Now 2 more. So let's quickly do this. That is inserting and removing anything from the start, just like we did it for the last 2 values. So for that, let's quickly check the pseudocode. This one is quite easy. For arrays in JavaScript, it's shift and unshift for the front. Exactly. Pop is the last value and unshift gives you the first. All right. So now let's talk about shift, which is removing from the first value, removing the first value, basically the head node. So if the head is empty, that means that we have an empty list. We just simply return undefined. If that's not the case, we set the current head to the next node because the current head has to be removed. So we set it to the next node and then decrement the length by 1. And then if the total length is 0, we make the tail null and then return the old head. So let's do this. So here we will do shift. And then what we need to do here is we check if the head node is empty. So this dot head is, if this is not, if this is empty, we just simply return undefined. But if that's not the case, and then also we will do current node dot value. Now you may be thinking, what's the current node? So we will make that one right now. So current node dot, sorry, not dot, equals to this dot head. Now we need to remove this head. So what we do here is we do this dot head equals to this dot head dot next. So we just simply set it to the next node, and that's it. And then we do this dot length minus minus because we just remove one node. So we have to change update the length. And then the last is if this dot length equals to 0, we do this dot tail equals to null. You may be thinking why we are doing this. So let's say we have something like 2 and then null. In this case, the head node and the tail node, both of these are 2 because we don't have a tail node here. Like we don't have another node. So we just have this one node. So head node is 2, tail node is 2. So if we do this dot head equals to null, this dot head equals to next, so that means that we are setting the next, the head as null like this. So we fix the head, but the tail is still has the access to the 2. So we also have to make sure that we update the tail. So that is why what we do here is we set, if we see if that this dot length is 0, which is the case. Just a second. Yeah, so which is the case here, null. So in this case, we also have to update tail and it should return null as well. And then we can simply do return current node dot value. And that will give us the value which we just popped off, which we just removed. So now if we try to do this, let me do this dot shift. This dot head dot next is not a function. That is interesting. So let's see. Yeah, this is definitely not a function. So this should be this dot head dot next. And here we go. So length is 2. That makes sense. Head is 5. That makes sense because 2 has just been removed. And the tail is 10 with the next node as null. So yeah, that also makes sense. So yeah, that is a pop function. Super quick and easy. Any question about the pop function? Any confusion? I would appreciate if everyone can give me a thumbs up if you are getting this. Awesome, awesome, awesome. Thanks. All right, so let's go over the last function, that is unshift, which is exactly the opposite of shift, where we are adding a new value in the start. So the way it works is we create a new node, of course, because we have to insert something. And then if the head node is null, we simply just set the head to the new node and set the tail to the new node, exactly the same way as we did for the push when the head was empty, exactly the same thing. But if that's not the case, which means that if head is not null, we set the new nodes next to the current head node and then set the head to the new node. And then, of course, we increment the length. So yeah, let's go correct this function. And here we go. So this is unshift. So we will write unshift and then the value. And then, so here for the unshift, what we do here is we create node that is this node, of course, a value. Exactly. And in unshift, we put a value in the front. I mean, for example, if this is like 2, 5, and 10, and if I do unshift of 3, so that will be 3, 2, 5, 10. So yeah. So this new node and the current node, etc., this may be confusing to you, but what I'm trying to say here is set the new nodes next to the current head node, which means that this is node. So nodes dot next equals to this dot head, and then this dot head equals to node. So yeah, that's exactly what we will be doing. So we have this node, and then if this dot head, which means that if there is no head, what we simply do is we do this dot head equals to, I will make this new node. So it makes sense. Okay, new node. So then here, this is new node, and then tail is also new node. All right. But if that is not the case, we already have something in the list. So what we do here is we do new node dot next equals to this dot head, because this is going to be the new node, and then this next value is going to be what's currently then the head. This new node is going to be the head. Okay, so and then this dot head equals to new node, and then lastly we do this dot length plus plus, and then it's up to you, either you want to return the length, this dot length, or you want to return the new value that you inserted, but I will return the length. So what happens here is, let me give you a quick idea. For example, if you're 2 and then 5 and then null, so we have a new node. So let's say we created a new node that is new node equals to 3. So what happens here is we set the, in this case, we set new node dot next equals to head. So we have this new node, which is 3 dot next equals to 2. And then currently the head is at 2, but we set this dot head equals to new node. So the head moves from 2 to 3. So now when you do this dot head, so it will give you 3. And then when you do this dot head dot next, it will give you 2. So we just inserted a new value here in the head, in the start. So exactly the opposite of push, where you add a new value at the end, and unshift helps you to add a new value at the start. And that is how it works. So let's test this, and I will remove this, comment this, and then unshift and add 3, and let's test this. So it has a length of 4. Yes, that makes sense because we have 4 values. So let's see what's the head. The head is 3, and the 3 has a value. 3 has a next value of 2, and that totally makes sense. So yes, 3 has a next value of 2. So that makes sense. So yeah, that is how it works. Any question about the unshift, shift, push, pop, etc.? Give me a thumbs up if this all makes sense to you. All right, awesome. Since we just have 4 minutes left, what we can do here is, so there are 2 more properties that's super basic, super simple, not super simple, but simple. That is the that is the get value and then the insert value. So get value is basically when you give it an index, so it returns to you that value on that index. And then the insert is you give it an index and a value, and it insert that value at that specific index. Now, I have the pseudocode for this. I will share this slide somewhere with you. Probably add this to the LMS, to the week 4, and then you can go through this. And I would highly encourage everyone to try this on your own. And yeah, so just because we have just 5 minutes left and we cannot cover this in that 5 minutes. But yeah, here's the pseudocode. Feel free to try this on your own. And then if you have any problem, any issues, ping me in the additional events, fellowship events channel, cracking the coding interviews channel. Sorry. So yeah, with that being said, if anyone has any general questions about interest or about what we just studied, feel free to ask. I'm getting it, but just need to review the base class of the first practical example. Do you want me to show something specific on the screen? Writing. All right. All right. While you write this, just a quick thing here. So as I mentioned this last time, so there is an assignment every week for the CTCI. Now this is for you, to help you to eventually be a better, to get better at the CTCI, cracking the algorithms and data structure, and eventually be better at performing good at those technical interviews. So there is an assignment which you will be able to see in the LMS in the week 4, which will basically have a deadline of 1 week. And it has a question of the HackerRank, just like the last time, with some lead code, with some ranked list questions. So please make sure that you complete that on time. Your pod reader is your point of contact for if you have any kind of difficulties for that. And with that, I will share this quick survey if everyone can fill that out. How do we get the assignment? So that assignment is already there in the LMS. It should be there. Actually, let me quickly check this. Meanwhile, if you can fill this survey, and then do you have assignment in the software track? No, it's only for the SRE engineers, because this is something mandatory for the SRE. It's not for the software engineers. So if I go to the week 4, it should be somewhere here. If it's not, I will ask the person to add this. Yeah, it seems like I cannot find it, but am I in the SRE? Yes, I am. All right. This seems to be it's not here, but I will make sure that it's here in the next 10 to 20 minutes. I figure SWE should have it. I would suggest you to maybe you can go through the HackerRank question on your own. The reason we don't have it for the SRE engineers is because SWE engineers, SWE is because we do not want you to have some extra work, which is basically not something that you must need, but it's good to have. So feel free to do it on your own. But yeah, I will get back to Nathalie's question. The push method, I will take a screenshot. Okay, if you want me to show you the code, so here is the code if you want to take a screenshot of this. Also, the recording is going to be public, which will be available in the events recording. So feel free to go through this all over again. Can you make it up? All right. Perfect. Once again, here is the feedback survey. I would encourage everyone to please make sure that you fill this out because it's also going to help you to be on the top of the leaderboards. So yeah, and that is pretty much it. I hope you all had an amazing day today. And with that, I will stop the recording.